Good evening, everybody. Thank you for joining us this evening for this winter weather workshop brought to you by Astral Aviation Consulting on behalf of the UK Civil Aviation Authority. If you'd like to stay in the loop with events and resources, please do sign up to our mailing list. You can do this by going to our website, www.astralaviationconsulting.com, or use the link that's just appeared or will be appearing shortly in your chat box. Signing up also gives you access to the replay of this workshop and a whole host of other safety resources. Speaking of chat boxes, please feel free to let us know where you are. I'm personally up in cold and dark Shropshire this evening, looking to go flying tomorrow, so hopefully we'll get some good news about the weather from our two weather presenters this evening. I'm delighted to be joined once again by Matt Lane, Dr. Simon Keeling, and Joe Aston. Matt, as you will no doubt know by now, is the head of training for RAF sport aircraft and an active single and multi-engine FI and FE. Dr. Simon Keeling is a fellow of the Royal Meteorological Society, a one-time TV weather presenter, and the founder of Weather School. Weather School teaches pilots how to confidently interpret and forecast the weather so that they can improve their flight safety and get the maximum from their flying time available. You can find more about the course that Simon runs at weatherschool.co.uk. Finally, Joe Aston is the CAA Met Technical Officer and a qualified aeronautical meteorological forecaster for the Met Office with 15 years experience. She spent 10 years in defence at various UK and overseas locations, with a further 5 years in civil forecasting at Heathrow, both on the forecast bench and as the manager. Welcome to you all. Over the course of the next 90 minutes, we're going to break this workshop down into easily digestible chunks. And we're going to cover some snow, icing and fog, funny old thing because it's the winter, before rounding off with how we apply this information, and that's where Matt's going to lean in with his experience, how we're going to apply this as pilots, and some top tips for staying out of trouble. Then, of course, it'll be time for Q&A at the end. As always, we'd love you to get involved with our polls throughout the workshop, and please do add any comments you have in the chat box, particularly if you want to share any learnings you may have come across that might benefit other people. If you have any questions, then please do ask them via this Q&A function. So please use that separate box you can see on your screen, and we'll endeavour to answer them either as we go or at the end. So let's crack on. But to kick us off, I always like to start with a poll. So instead of finding out who's with us this evening I'd like to find out whom of you are affiliated or a member of any flying organisation. If you are, which one? If more than one, then as the poll is single choice, then go with the one you interact with the most. So are you affiliated or a member of any flying organisation? If so, which one? If more than one of those listed, so if you are a member of AOPA and the LAA, for example, and also your local flying club, but you interact with the LAA the most, then put down option B. Equally, if you're not affiliated at all with anyone whatsoever, then please choose option C. Great, thanks. Let's have a look at the results. So lots of you, so 59% local flying club, so similar to me. Larger organisations, 32%, and a handful, a minority of none. So brilliant, thanks ever so much. It's good to know. Right then, so that's enough of the intro from me. Let's kick off straight with Simon, please. He's going to talk to us about some snow. Over to you, Simon.
Thanks, Chris. Good evening, everybody. Great to be with you again this evening. Yeah, I get to talk about snow this evening, so it's like being a kid again, isn't it? As we get towards Christmas, we all think of those wonderful Christmassy scenes. Not so great for us as pilots, and I'm hoping to tell you a little bit more about snow and just get us thinking more about snow over the next few minutes. But first of all, as Chris said, we love a good poll. So why not go with another quick poll? And this is one for you, just to get the old juices flowing a little bit. On a METAR or TAF, what weather does RASN refer to? So on the METAR or TAF, what weather does RASN refer to? Is it rain? Is it hail? Is it freezing rain? Or is it sleet? I.e. rain and snow. Which one of those two, those four even, I can't count this evening, which one of those four do you think it is? I'll just give you a few seconds to get your votes in, and then we'll take a look. Okay, rain, hail, freezing rain or sleet. Let's have a look at the results and let's see which one it is. Yeah, see, you're all there with it this evening, aren't you? I knew you would be, you clever bunch. It's sleet, rain, and snow. Now, it's actually a little bit of a trick question, this one, because, well, actually, it wasn't that tricky, was it, for most of you? Because most of you got it right. I did throw the freezing rain one in there, which was a bit of a confuser. That's because there's officially in the UK, there's actually no official definition of actually sleet. It's always defined as rain and snow, and that's laid down by the World Met Organization. It's a protocol that the Met Office follows as well. So the definition of sleet is actually rain and snow. So whenever we talk about sleet, it doesn't really exist. It's always rain and snow. And us meteorologists, we love our definitions, as you know, from previous sessions. We do like a good definition. For me, though, this mention of rain and snow in the METAR TAF Form 215 or on Garmet is a massive red flag when I'm planning to fly. And that should really warn us all as pilots of ice, which, of course, Joe is going to be talking about next, and even the risk of icing conditions. So Joe's going to tell us more about that. Okay, then, so let's start to think about snow and how this affects our flying. Of course, Matt's lined up with practical examples, but for most pilots, snow is an absolute no-go. And I have to say, I put my hand up to that one as well. If it's mentioned in the forecast, I think most of us will just avoid it at all cost. Although, of course, there are times when we can be caught out. So I think what we'll do is start by defining what snow actually is. And this is a whole topic on its own. And in fact, there are academic careers that have been based on the study of snowflakes. Can you believe it? Yep, there are people out there who study how they form, how they interact, and the effect that they have on the atmosphere. In fact, course in applied meteorology as an honorary lecturer there, and I've got students who are writing dissertations on snowflakes. They are important. These little things that come down out of the sky really do have a major impact on the weather, on both the creation and also destruction of weather as well. So these are some photographic plates from the 1902 archive of Wilson Bentley. Wilson was a farmer whose hobby was photographing snowflakes, and just looking at the intricacies of the patterns of these is just amazing, isn't it? And how every one of those snowflakes is different. It's these differences that cause some snowflakes to clump together and give us fantastic snowball snow. Remember that as kids, running outside and grabbing a handful of snow that just disappeared away. Or those mornings when you ran outside and you grabbed the snow and it stuck together, and you knew that you could throw it as your brother or your sister or your mates, and when it hit them, it was really going to hurt. Remember that? So I certainly do. And of course, it's that snowball stuff as well, which can stick to airframes, or more readily sticks to airframes. So when might we actually get snow? I'm going to concentrate more on the UK and Ireland, but this applies as well to much of Northern Europe. And in these areas, there's a risk of snow falling from about mid-November through to the middle of March. As a meteorologist, as forecasters, we kind of start to think about mountain snow in Scotland around about the middle part of October, but we don't start to think about more widespread snow events until the middle of November. And in fact, over the last sort of week or so, with these areas of low pressure tracking across southern parts of England, the chat in the meteorological community has been, if this happened another 4, 5 or 6 weeks time, we could have been looking at snow rather than heavy rainfall events. And the reason for that, of course, is at this time of year, temperatures are falling quickly as the length of the day shorten and things just get generally colder. So that sort of mid-November through to mid-March period is the time that we're thinking more about snow. So let's look at a typical winter frontal situation. And our snow usually comes from two weather regimes. So very often these are sort of what we look at as forecasters, is a warm front moving in from the south or the southwest, and what I also call air mass snow events. I think I've explained before that as forecasters we kind of have a toolbox that we go to, that we pull out these individual tools which are going to be useful on any particular day, because of course as forecasters we can't just have this whole range of things that we look at every single day, because we never get a forecast out. So what we tend to do is to look at a synoptic chart like this one, and we make a decision as to what tools we're probably going to need on any particular day to grab out of the box and start to forecast with. So this idea of fronts moving in from the south or southwest has snow all over it when we're looking at winter, and also, like I say, these air mass snow events. So let's just look at this frontal situation first of all. And we can see here that we've got a warm front, and the warm front, remember, on these charts are those semicircles, and those semicircles point generally in the direction to which the front is headed. Now, a couple of things to note on here. The distance apart of the semicircles bears no indication as to how fast the front is moving. They're always a standard distance. And also, if the fronts are hollow rather than filled in as they are on here, that means something slightly different about that front. But if we see a front like this with a semicircle on it, then that is going to be a warm front. And here the warm front is moving in from the south into colder air, and this is a classic situation going into the winter months, where to the north of the warm front we've got an easterly wind, to the south of it we've got a southwesterly, and what we find is rain turning to snow as this front moves northwards and reaches colder air. So in this scenario, what we usually see is precipitation starting as snow and lasting for a few hours, perhaps bringing a heavy fall of snow before milder air arrives and turns the snow back to rain as the warm front passes through. Now, actually, this chart bears a lot of resemblance to some of the charts that we've seen over the last couple of weeks. And this is exactly what I meant about if we'd been sort of 4, 5, 6 weeks down the line, we would have been talking about snow events across the UK rather than just rain. And it would have been significant snow as well, because we saw that much rain, didn't we, over the last couple of weeks? Imagine if that were to be snow. Now, the other thing to consider as well, when we see a situation like this with the front coming in from the south, is that there's a major icing risk. But of course, Joe's going to tell you more about that. So a frontal snow situation, one of the main frontal snow situations that we look for is something like this. And one of these situations is where pilots can get caught out. Now, these days, the TAFs form 215, and also things like the gamettes are really good at picking out these sort of situations and predicting snow events much better than they have been in the past. But still, you know, this is forecasting. Things can go awry at times. So when we see this going into the winter months, we do just need to be aware that there is that risk of snow. Now, what about these air mass snow events that I talk about? Well, typically these events occur because an air mass has brought cold air with it. Remember that air masses, and again, I've said this to you before, that the air masses are kind of like bad friends at a party. They traverse the globe as lumps of cold and warm air, and they kind of will cast each other a glance, but they're never really going to get on, so they're never really going to mix. So what we find are these big air masses of cold and warm air that move around the globe, fronts marking the boundary between those air masses. But there are certain air masses that can bring snow events. Now, something that we also need to make clear when we're talking about snow is that for forecasters, it's a bit of a nightmare, particularly when we're forecasting in the UK, because the temperature sits so close to that switchover point as whether there's going to be rain or snow. Models do help, but because of the temperature interactions that are going on with the process of freezing and thawing of snow and of rain, it can really make forecasting very, very difficult. So I freely admit that when we're snow forecasting, it isn't necessarily one of the best areas of forecasting that you're likely to see. But you know, we're all aware of it, and we try our very best. So there are three main air masses that we need to watch out for that cause these air mass snow events. So these are polar maritime, Arctic maritime, and polar continental. So what we're going to do is just start with polar maritime air. And the polar maritime air mass, as its name suggests, originates at the North Pole. So it's dry and it's cold air. And then the wind flows over the warmer ocean to the northwest of Scotland. Those arrows should just be a little bit further across, pointing to the isobars that are to the west of Scotland and over Ireland. So that's that northwesterly flow. And what happens is that we get very cold air that flows over a warmer ocean, and that causes the air to destabilize. So the temperature lapse rate, the change in temperature from the surface to higher levels, gets increased. And because of that, we get cumulus clouds, we get cumulonimbus clouds, and we get showers forming as well. And because the air is cold, precipitation is cold, the precipitation within it during the winter months will be frozen, and therefore we get wintry showers, many of these consisting of snow. Now, most of the showers over windward facing coasts and hills, some of those are going to be heavy at times, but for flying, this isn't actually too bad an air mass, particularly across more eastern and southern areas. Just one pointer to note on this chart, and it's a feature that isn't often on the chart. Can you see that kind of extending from the Midlands through Merseyside, running up through the Irish Sea and into southwestern Scotland? See that line with those little branches that are coming off that line? That's a convergence zone. So what's happening there is when we get that, that is a line, think of it as a line of heavy showers aligned with the wind. And whenever we see those lines, expect persistent showers. Now, often those showers will just be heavy. They might go a little lighter, but then they'll get heavy at times as well. So whenever you see one of those charts, just be aware of that. Okay, so what about the Arctic maritime air mass? Well, in the Arctic maritime air mass, the source of the air is the Arctic Ocean. So in the Arctic Ocean, it's frozen most years, north of about sort of 65 degrees north in the winter. Now, the air that flows over the ocean is deeply cold, and as it flows over open water to the south of around 65 degrees north, the bottom of it will warm rapidly. Then that causes the air again to become deeply unstable very quickly, and that enables deep convection clouds, cumulus and cumulonimbus, to form. And it's these showers that produce it's these cumulus and cumulonimbus clouds that produce heavy showers of sleet and snow, mostly over northern and western hills and coasts. And on this chart here, you can see the trough lines that have been drawn in, those black bold lines to the west of Scotland, to the east of Scotland, showing us where areas of heavy showers are. Now, western and southern areas tend to fare better, but you should still be on the watch for some pretty hefty snow showers. And then polar continental air. Well, this is the third air mass to watch for. And this is the one that produces snow coming in from the east. Remember the beast from the east a few years ago? Well, this is that air mass. And notice on this chart as well, we've got more of those convergence lines showing on there. So this air originates at the North Pole, hence the reason for it being called polar. Then it flows over Scandinavia before arriving to the UK from the east. And actually this air is actually rather dry, but because of various different factors, including pollutants from Europe and some moisture getting picked up as it crosses the North Sea, we can find quite shallow cloud, and this produces snow flurries, particularly in the east. Some of these can penetrate further west, but in this situation, the east usually sees most snow, the west usually see the best conditions. Now, of course, in these situations, you're not always going to get snow, but these are the ones that we need to flag up for a risk of getting snow at times. Okay, so that's the fronts, that's the air masses. What about forecasting snow? Just a couple of quick rules of thumb for you. On form 214, question to ask yourself is the temperature at 5,000 feet minus 5 degrees Celsius or less? If it is, then there's a high chance the precipitation reaches the surface as snow. So just a real ready reckoner for you. By using form 214, you can just have a look at those temperatures about 5,000 feet, see what they are. Use -5 as your sort of telltale for the risk of snow reaching the precipitation reaching the surface as snow. Don't run away with the idea that this rule of thumb is always going to work. It's not, but it's a good indicator. Now, secondly, and a little more technical, is the snow line. Okay, so this is a line that we see on the Met Office charts from about T+36 hours onwards. Well, not from about T+36, it is from T+36 hours onwards. So we've highlighted it on this map here. There's the 528 line. Now, I'm not going to go into detail on what 528 is, but if the value of this line over the area you're interested in is 528 or less, then there is a greater than 50% chance of precipitation reaching the ground as snow. Again, just a rough rule of thumb, but by using that 528 line, we can, as pilots, give us a quick idea, a rough idea as to what the likelihood is. So just to repeat it for you, if the 528 is 528 or less over the top of you, then there's a greater than 50% chance of precipitation reaching the ground as snow. Okay, well, I've hit you hard there with some snow information. We could go on for hours about snow and about forecasting snow, but I'm not going to, because Joe has some fantastic stuff for us now coming up on icing. And of course, as a pilot, we can never know enough about icing. So believe me, I'm going to be all ears on this one as well. I'll be back in a bit.
Lovely. Thanks ever so much, Simon. Well, so if there ever was someone that knows so much about snow, Simon is your man. So get those questions in, all those snow-related questions coming to Simon, please. Yes, let's move on now. Joe, icing. Wowers with your icing knowledge. Let's go.
What an introduction.
Exactly.
No pressure.
Over to you.
Thanks so much, Chris. And thanks, Simon. That was a really good overview of snow. So I think we'll just start, as we usually do, with a quick poll. And I've got a little question for you. So how many official types of icing are there? 3, 4, 5, or 6? Give you a few seconds to pick an answer out of those. Okay, let's have a look. Hopefully everyone's managed to put in an answer. We'll see what we get. Okay, so the answer is 5. There's a few of you managed to get that. And yeah, the answer is 5, officially 5 types, different types of icing. And so we'll just have a look and see what those are. And they are rime ice, clear ice, or glazed ice, as it's sometimes called, mixed ice, rain ice, and of course hoarfrost as well. So when I first learned that I was going to be presenting the section on icing, I have to admit I was a little bit daunted. It certainly wasn't my favourite subject when I was doing my forecaster training. It's quite complicated, and similar to snow, we could talk about this all evening. There's quite a lot to get through, but hopefully I'll give you a reasonable overview, and please feel free to pop any questions into the chat. Okay, so generally you won't hear ice talked about in its specific categories. They're usually kind of lumped all together as just icing, and we're also only going to cover airframe icing tonight. So before we move on, let's have a quick look at effects that icing can have on aircraft. So I was just wondering if you could pop in the chat. I'll just give you 30 seconds. Any effects that you can think of icing on aircraft? Go.
Oh, look at that.
Woo.
We're flying in.
Yeah.
We should do this more often. We need a countdown clock now.
Oh my goodness.
Literally flying in.
Cool. 10 more seconds. Wow. Okay.
Fantastic.
Brilliant. Fantastic. Thank you, everybody. So I'll just pop the next slide up if you could, Chris, but I'm not going to linger too much on this one because clearly you're all well aware of what some of the effects can be. And there's a number of them, and icing is quite a severe hazard when it comes to aviation. And some of the things to kind of bear in mind is generally the sharper and pointier the surface, the more prone it is to icing. So your tail fins, propeller blades on helicopters, radio antenna as well. Okay, so we won't linger too long there. So what do we need for airframe icing? So this normally occurs when the air temperature is below 0 degrees C, and we have something called a supercooled water droplets. Aha, so what supercooled water droplets, I hear you ask? This is a water droplet that remains in liquid form at very low temperatures. And normally, to become ice, it needs something to cling onto. It needs what we call an ice nuclei. And if it doesn't have that, then it can't become solid, so it remains in liquid form. And hopefully this slide here will help to illustrate where those pesky supercooled droplets might be. So at the bottom of the pretty illustration of a cumulonimbus cloud, we mainly have rain at the very bottom. And then in the kind of 0 to sort of -10, -15 range, you're looking at mostly supercooled droplets. And then as we go higher up in the atmosphere, kind of -10 through to -20, so some ice and some supercooled. And then at the top, it's mostly ice, and then very top, we've got all ice. So some couple of things to be aware of. Vertical motion can help to enhance icing. So beware of the convective clouds that are sitting on or just above that 0 degree isotherm. Essentially, the more ascent you've got of air, more cooling you get, and therefore there's more water vapor to condense into liquid, and therefore more liquid water droplets that could be supercooled. So another common location for that is around kind of hills and mountains where you see some vertical motion over the top of that. So again, two kind of key things to watch out for there. You can get icing in stratiform clouds in the same temperature bands, but generally it's not normally as severe. Although one to watch out for is nimbostratus, and that's due to its kind of quite large vertical and horizontal extent. Okay, so let's go back to our 5 types of icing. We're going to start with the first 3, and these are the ones that are most commonly found in cloud. So the first one's rime ice. This is quite rough, it's opaque, it's milky, it's quite brittle, and can interfere with the kind of wing efficiency. Generally, it's pretty easily cleared by de-icing equipment because it's formed by quite small water droplets. The next one is clear or glaze ice. So this is, as the name suggests, it's clear. It's quite tough and adhesive and quite heavy. And even with any de-icing equipment, you can still get build-up. And it can actually kind of run back along the edge of the wings, and you get these kind of horn-like features, which you can see in that bottom photograph there. It is one of the most common in cloud icing types, partly because it occurs in the range of temperatures that are kind of -3 to -10, so probably the one that you're most likely to see. I mentioned it's commonly found in cloud. It's not always the case, is where it starts to get a bit complicated, but glaze ice can also form when you have drizzle or rain that's hitting a surface that's really close to 0 or even below 0, but we'll come back to that. And then finally, there's mixed ice, which is exactly what it says. It's a combination of the other two. It's dense and heavy, it's very disruptive, and sometimes de-icing equipment can be ineffective with that. Okay, so on to the really fun ones. So this is rain ice, or you might hear it referred to as freezing rain or freezing drizzle. It's a sort of form of glaze ice, which we just looked at. Again, it's very similar properties. So clear, it can lumpy, uneven, very heavy, and it can result in really extreme icing and make any type of anti-icing equipment ineffective. I figured it was worth spending a little more time on this because it is considered one of the most extreme forms of icing, and it is a significant flight safety risk. So you remember just now I mentioned that glaze ice is often formed when drizzle or rain hits a surface that is below 0 degrees C. Freezing rain's similar, but in this case, the droplets themselves are also below 0 degrees C. And it most commonly occurs just ahead of a warm front during winter. So we're back to those warm fronts that Simon was talking about earlier with the snow. So I'm going to get a little bit technical, but hopefully you can bear with me, and the next slide will help to just kind of illustrate this. And hopefully will also help to illustrate some of the points that Simon made as well during his snow presentation. Okay. So here we have a tephogram. Some of you might be familiar with these. It's essentially a way to display the temperature and humidity through the atmosphere. And it's a really key tool that forecasters use when they're looking at cloud. At the bottom, you've got your ground surface, and at the top is the tropopause. The solid black line is air temperature, and the dotted black line is your dew point, with the red line being the 0 degrees C. And essentially, when the two lines come together, you've got high humidity, and therefore you've got cloud. And this information is commonly gained through a radio sonde or weather balloon launch. And in this case, what we're most interested in is that black solid temperature line. So you can see at the bottom, at the very surface, the air temperature is just slightly above freezing. Then as we move a bit further up, there's a layer where the air temperature is below freezing, and this is known as a sub-zero layer. Going a bit further up again, the air actually gets warmer. So what happens is precipitation high up falls through that warm layer and melts, becoming liquid, but then only then to fall through that sub-zero layer close to the surface where it cools, doesn't quite have enough time to freeze, and then hits the ground or your airframe. If you think about a classic warm front, the picture, the kind of small picture in the box hopefully shows that. You have colder air at the surface, and gradually that warm air rides over the top. And you can probably appreciate that the sort of thickness of that warm and cold layer, and just how cold the actual air is at the surface, all plays a part in determining whether you'll get snow, sleet, freezing rain, or just plain old rain. And similarly to what Simon was talking about with the snow situations, you can see that you can get a real mix, and sometimes you'll get all of it, sometimes you'll get none of it, and that can make forecasting snow pretty tricky. You'll be happy to know that true freezing rain like this with super cool droplets is not particularly common in the UK. It does happen, but not very often, and that is because of those subtle dependencies that I was just talking about. More common is the sort of glaze ice where the rain falls onto a frozen surface. And although they are slightly different mechanism, the impacts are very similar. And because of this, the term freezing rain is often used interchangeably for both, and particularly, by the media as well. Although the Met Office issues warnings for freezing precipitation, the definition is for liquid precip with an air temperature of below 0. So it doesn't really account for that kind of situation where you've got kind of normal rain and it's falling onto the freezing surface. So that's just something to be aware of, that those freezing precipitation warnings are only for truly defined freezing precipitation. So we'll just have a quick look at the warnings. So the Met Office obviously issue plenty of warnings for all sorts of different things, and this is just one example. The warnings tend to be a very similar format with standard wording, and in particular you'll either receive a may or a likely warning. This is the one for freezing precipitation. So rain may freeze on contact, and that may is issued when there's up to a 40% chance of the situation occurring. If you've got a likely warning, then likely is when there's over 40% chance of the situation happening. Essentially, if you've got temperatures at the surface of around or close to freezing, and you see that warm front approaching on your charts, as Simon said, the risk of freezing rain or snow, that should always be a consideration during the winter period. Okay, so moving on, hoarfrost. For this, you need runway surface or airframe to be below freezing and below the dew point. It's reasonably straightforward. You've probably all seen it plenty of times. In the autumn, we see this as dew, but then as the temperature falls into winter and surfaces can quite quickly cool below 0, even with a positive air temperature, we see the risk of hoarfrost increase. So as a rule of thumb, if your air temperature is to fall between 0 and 4 degrees C on a night with little or no cloud and light winds, then you need to bear in mind there might be a frost outside in the morning. And interestingly, This is another winter forecasting is a lot of fun for us forecasters. But when Simon comes on to talk about fog, you'll notice that actually the conditions for hoarfrost or dew formation are very similar to fog. So which one will it be? That is sometimes a big question for a forecaster of a night time in the winter. The other thing to bear in mind with hoarfrost is that it can form through something called cold soak. And this is when your airframe is below 0 degrees C and actually you either ascend quickly or descend into really warm, moist air. It's, all of a sudden that warm kind of moist air has something to freeze onto it, and that is your aircraft because it's below freezing. So a few final thoughts from me. So the first one is, this is an example of the F215. This is from last winter. We can see that there's the purple marked front on there is an occlusion, and that actually did move across the southern part of the UK and bring some snow in December last year. But I would say check your 215, consider things like timing, placement of the fronts, think about the air mass type for your location. Is it warm or is it cold? For example, is the front clearing really early in the morning and then your temperatures suddenly plummet, leaving a wet surface that's now below 0, risk of ice? Check the forecast temperatures. What height are the clouds? You might well avoid the cloud, but you could still have icing from cold soak or even glaze ice from falling precipitation out of those clouds. So we already talked about warm fronts, in a common very common location for snow and ice, and it can be up to 400 miles ahead of a warm front. So that's a really big area to kind of bear in mind. And similarly, on or up to 100 miles either side of a cold front as well. You'll notice on that F215 chart, there's a whole bundle of fun things on there. So I've just highlighted a few, but in area B, you can see how at the top, we've got ISOL 7 kilometers, and there's SHRAGS, which is small hail, as well as normal showers around the seacoast. There's SHRASN, so that's Simon's rain and snow mix, those sleet in there. There's showers of snow, just normal snow, and SG, which is snow grains as well. And then on top of all that, there's a possibility of some fog and some freezing fog as well. So quite a lot going on there. On the other side, in the cloud section, again, you can see the symbols for moderate icing. So moderate and severe icing will always be noted, as will anything that's freezing, so freezing precipitation or freezing fog. So in conjunction with your 215, I definitely recommend as well having a look at the gamut. This is the gamut for that same period of time as that last chart, the F215, and this is for the kind of southeast corner of the UK. But you can see how it gives quite a lot more detail around that sort of specific area. Got much more detail around the freezing level. You've also got a lot more detail in that second middle circle that's highlighted of the cloud heights, the cloud layers, and the weather that's likely to be associated with those, as well as some information about what warnings have been issued and are valid at that period of time. So in this case, hill fog, moderate ice and turbulence in the cloud, and severe icing and turbulence in any CBs or thunderstorms. So it's quite a lot. I've gone through quite a lot there in a kind of very rapid period, but hopefully that's given you a good overview of icing. Like I said, make sure you check your charts. Always kind of use the gamut and the 215 in conjunction with each other. And there's some great resources around as well, which I'm sure Chris will be able to kind of send out, including the Met Office Aviation Briefing Service. And there's also some good CAA resources as well, include around threat and error management with some kind of worked examples that can be useful as well. So hopefully I've not bored you all to tears with that or back to you with science.
I love it. I love the passion. That's why I love these weather ones, because Simon and Joe, the way you go about, you just love it, and it's fantastic because it definitely comes across. Okay, just having a look through the chat box. I was listening to you, Joe, but I was looking at the chat box at the same time. Honest. And Dave has mentioned he'd flown into Canada, and OAT
Ooh.
was warmer at 10,000 feet than it was on the ground, so it's obviously pretty cold in Canada. So anyone else out there, where's the coldest place you've flown into? Let us know. Let us know in the chat box. It'd be really interesting. Where did I go? I think, Canada for me, I think it was.
I was going to say Canada, East
Pretty
Coast
cold.
of America, Nova Scotia, absolutely, and they regularly see true freezing rain there, because they just get the right conditions for it.
Yeah.
Yeah.
I think it was it Maine? I think it was Maine. Yeah, East Coast of the States, I think, for me, or Canada. Lovely. Okay, that's a bygone era. Right, let's move on. Back to you, Simon. Thrillers with some fog.
That's not a phrase you hear every time, is it? Yeah, okay, so fog. Just going back to what Joe was saying there and showing that those gametes are just brilliant. You know, I keep saying to pilots when they say, oh yeah, I look at them, but I don't want to read all the way through. Teach yourself to look at those and read through them. The amount of information that is in there and that's ignored by the majority of pilots is just stunning. So get yourself used to using those gametes. You know, if the information's there for us to fly with, let's use it. It's a use it or lose it, isn't it? So brilliant. Great stuff there. Thanks, Joe. I'm going to use a lot of the information you put in there. It's a real good refresher on ice. So ice forecasting, bit of a nightmare. Fog forecasting, another nightmare for forecasters and pilots alike. It's the bane of our lives. But you know, we try our very best with it, and it does keep us on our toes. But what about keeping you on your toes? Let's have a quick quiz. Let's have a look at this. In aviation, what is the definition of fog? When visibility is less than 500 meters, less than 1,000 meters, less than 200 meters, or less than 150 meters. So which one do you think? Have a go. Is it less than 500 meters, less than 1,000 meters, less than 200 meters, or less than 150 meters? Which one of those do you think it is? Just give you a few more seconds to put your answer in, and then we'll have a look at how you've all got on. Let's see what you think. Well, the correct answer was B, less than 1,000 meters. 33% of you got that right. But you can see there quite a variance in the answers, which is very interesting, because it is one of those things that we think of with fog, and we never really think of the true definition of it, do we? But for aviation purposes, that's when visibility is less than 1,000 meters. If it's above 1,000 meters and the atmosphere is obscured by water droplets, then that becomes mist, but less than 1,000 meters is fog. Now, what's interesting here is that when we listen to radio forecasts or watch TV forecast, the forecasters on there use a tighter definition for fog, generally less than 200 meters. So quite a discrepancy there between the two. But I don't know about you, when I'm flying my little aircraft, 200 meters or 1,000 meters, I ain't going flying. And it's as simple as that. Okay, so let's get on with fog. And there are several different types of fog. And again, like I was talking about snow and like Joe was talking about with ice, we could just write a book on each of these topics. Okay, so we're trying to condense them down into a few minutes. And fog is one of those, but we can have hill fog, we can have advection fog, we can have radiation fog. Now, for the purposes of winter weather planning for flying, it's going to be radiation fog really that has the most impact on most of us. Although, of course, we also don't want to be any of those in any of those other types of fog either. Now, just a note on hill fog, because going back to Form 215, one of the frustrations that many pilots tell me about on weather school when they're using Form 215 is, oh, well, it always says hill fog. Well, yeah, of course it will on the majority of days say hill fog in the UK, because if you've got a cloud base of less than 3,000 feet, most of those areas that we see across the UK, most of those areas on Form 215 will say hill fog, because there will be fog shrouding hills. But don't let that put you off 215, you know, just because it's there. That's the reason why we have hill fog mentioned, but it shouldn't stop you from reading the rest of 215 and making real good use of it. Okay, so as I say, in this section, we're going to focus on radiation fog, and that's going to be closing out tonight's session, because no doubt your heads are full of weather, and our intention is that you don't sleep tonight because you've just got weather going around in your head. So let's have a look at radiation fog and how you can better forecast it and perhaps spot the chances of development days in advance. And again, I'm kind of showing you one of the tools in the toolbox that forecasters use. And we kind of use this sort of tick box to say initially there's a risk of fog, and then we will kind of drill down into the detail of what the atmosphere is doing to try and refine that idea of a fog forecast. So what I want to do is to try and help you spot the chances of fog developing a few days in advance. So radiation fog is the fog that we will see on winter's evenings and mornings. It's caused by falling temperatures, and it forms because the land is cooling to its dew point. And what that does is it allows condensation to occur. And so long as the wind is light enough, we're going to see that water condensing out as water droplets. Now, at high levels, that's cloud. That's what we see at cloud as cloud. But at the surface, we're going to see that as fog. But what are the ingredients that we need for radiation fog to form at our airfield? What are we going to look for? It's really important to note with this as well that each individual airfield has its own set of local effects that can impact whether radiation fog forms or not. If you read any of those wonderful books written about flying during the Second World War into some of the airfields that we've now lost, you'll see very often how the pilots describe fog forming rapidly at an airfield, and suddenly them getting into trouble with that. And very often that's because the fog just wasn't forecast because certain set of circumstances changed. But they would have followed these rules that I'm about to show you now on the ingredients that we need for fog. So this is your fog recipe. It's a bit like Bake Off, isn't it? Firstly, what we need are clear skies. And you can spot these in the forecast, perhaps with the TAF listing few or scattered clouds. If the skies are clearing towards dusk and then are expected to be clear overnight, that should set an alarm ringing in your head. If the cloud increases overnight, then that would have the effect perhaps of bringing up temperatures, and that will allow any fog that has formed to clear. You'll notice that I'm using the phrase perhaps, usually, most of the time, quite a lot here, and as forecasters we do tend to do that because don't forget we're dealing with a chaotic topic. So you know what I'm showing you here applies most of the time. Now, ridges of high pressure are also areas where we can find clear skies, and the winds within those ridges may be light as well. So spotting those on the charts is a sign of fog. We need light winds, and for what I call decent fog to form, I mean, it can only be a forecaster who talks about decent fog, proper fog. What we want is for the wind not to be completely calm. 3 to 7 knots is perfect for the formation of fog because this mixes up the atmosphere and creates the right conditions for a depth of fog to form at the surface. Also, we want moist air. So by this we mean that something like a wet ground, which of course we've got plenty of here in the UK at the moment, and an air mass with low temperature or dew point spread, and even a source of moisture like a lake, pond or stream. Now this wet ground thing is pretty important at the moment because we've not really had a set of circumstances yet which has led to clear skies and falling temperatures overnight over the top of what is wet ground across the UK. But as soon as that occurs, I think the incidence of fog is going to be pretty high. So do get prepared for that. So all of these factors that we've listed here will lead to fog forming. Now, as for the clearance of fog, this is one that I often get asked about as well. What are the best ways to forecast the clearance of fog? Yeah, if only I knew. Increasing winds, increasing cloud and drier air are all going to help fog to clear. But mostly though, fog will clear on a winter's morning as a result of the sun rising and the atmosphere heating up. And the top of the fog layer is also going to be heated by the sun. And the wind may pick up by a few knots as that heating gets going. And all of that combined will help the fog to lift. Now, there are no hard and fast rules for the clearance of fog. We had sort of nomograms in books in days gone past that we would work our way through to give us an idea as to when fog may clear. And they were pretty good. But as I've said before, each individual airfield actually experiences different exposures to wind and to increases in temperature. So it's really tricky to forecast. Now, when I first started forecasting, just as an aside, each of the airfields that had forecasters located at them used to have their own set of notes, their own little handbook that forecasters were writing over the years, notes that they'd spotted about when fog was likely to clear and in what conditions. I wonder what's happened to many of those, Joe. Perhaps you can tell us, but I bet many of those have disappeared from the airfields. But they were handwritten very often, these notebooks, and really they were excellent to give us a guide as to each individual airfield as to how fog was likely to clear. So just these are the rules of thumb I can give you for the clearance of fog. So what I would say in terms of timing, and remember, this is a very, very rough rule of thumb. If you've got nothing else, just throw this in and see how it goes. In October, clearance probably by about 10 o'clock if we've got proper radiation fog in the mornings. November is an 11 o'clock clearance. December, midday, but just be aware that could be an all-dayer through December as we get those really short days. January, we're back to about an 11 o'clock clearance. February, back to around a 10 o'clock clearance. And as I say, only use those in the absence of any other information, but at least it gives you something to work on rather than nothing at all. But as I said at the beginning, this is a topic all on its own. We could spend hours talking about fog, but hopefully what I've given you there is a little bit of an overview into fog, how it forms, how you can forecast it a little bit better, and also the clearance of it. I hope that helps.
Brilliant. Thank you, Simon. I think I've lost count of the amount of 10 a.m. clearances I've been sat around waiting for. Not at the expense of Joe or Simon, I might add. So, but there we go.
Yeah, we'll believe you, Chris.
Yeah. Lovely. Right. On to Matt now. We're going to talk about so what. So we've got a whole bunch of weather stuff. So what does that mean, Matt? What are we going to do with all this information now we've got it when we go flying? Over to you.
Brilliant. Thanks, Joe and Simon. Really difficult act to follow. So much knowledge there and that as well. Tell you what, if you're doing a pub quiz and Joe and Simon turn up, just forget it. Go home. You've lost. You won't win there. All that knowledge. So brilliant. Let's start this section. We're going to look at very quickly before we get into the Q&A. So what about all of that? What does it mean to us as pilots? Let's start with a poll. So we'll have the final poll for tonight. The outside air temperature is 5 degrees centigrade. So typical day. It was a bit like this morning, actually, when I was out on the airfield. The wind is 20 knots, which, again, not uncommon. What is the feels like temperature due to wind chill? 5 degrees, 3 degrees, 0 degrees, or -1? So here we go. Outside air temperature, 5 degrees, wind chill, 20 knots. Again, not uncommon. What does it feel like due to wind chill? And have a guess and see what you think. Right, let's have a look at how you got on with the answers. If we could have the answers to that. So yeah, the actual calculated answer is -1. So below freezing is the temperature effect you feel. A lot of people plumped for freezing, but it's actually -1. If you want to play around and calculate this yourself, just out of interest for different days as well, there's a good US government website, and Chloe's going to put the link to the chat box in there as well, and you can try lots of different calculations just to see how it affects. And it's amazing just how much that wind chill can bring the apparent temperature to you down. So moving on then, let's have a think about preparation. So what? So the easiest way to summarize this is it's all about time. It's all about leaving sufficient time. In winter, everything just takes that little bit longer. You know, you've got to get to the club. That might take longer. You've got to deal with snow and ice on the aircraft when you get there. You've got to get the hangar out. You've got the hangar open, the aircraft out. You've got to remove covers. You've got to take a bit more care about your planning. So everything really is just about leaving yourself more time. Winter flying is not the time to be, you know, trying to fit in that real quick flight, and you've got to take a work call, or you've got to pick the kids up, or whatever. You know, try and give some time. Now, in also your pre-flight planning and that, given the time of year, it's very likely that frost's going to form on aircraft parks outside during the winter. Now, if your aircraft lives outside, Parking it in a location that receives direct sunlight most of the day will help with that dispersal of the frost. If the aircraft's parked in shadow, moving it into sunlight can melt small amounts of frost on the wings. But if you're using that method, please make sure the controls are free of any water that could refreeze there on there as well. Now, small amounts of snow or frost can normally brush off using a broom or similar, but be careful not to try and scratch the aircraft there. You can see the chap there in the aircraft is using a towel to get rid of it. That's probably quite a good idea. Be wary of using car-style scrapers on windows, because aircraft transparencies are a lot more vulnerable to scratching than glass. Equally, large amounts of frost or water that's frozen can take longer to remove. If you've got lots and lots of frost as well, you may need to consider using an actual de-icing fluid that you can see in the example there in the photo. Remember, this needs to attack all the surfaces as well. So if you're flying something like Cessna 172, 182, you might need to get up on step ladders to access those higher areas like the top of the wings as well. If you're going to use de-icing fluid as well, please make sure it's an aviation approved one, such as Kilfrost. And it really isn't cheap. Any of you that have gone to look to buy or use this stuff, it is expensive, but it is really good stuff. And of course, it is properly approved for the aircraft and the components there as well. And a handheld sprayer, like you can see the gentleman there using, that's a good kind of thing. And you can get those off online stores or even garden centres as well if you want to use one to apply. Pay extra attention to the pitot statics as well, and make sure any system drains that may be fitted to the aircraft, you're making sure to get the water out. These are often neglected on check A's and pre-flight checks there. You can see a PA28 example in a photo I've put on there as well. Often people forget to press those drains there as well. Water in your fuel tanks as well can be an issue as well. So pay extra attention to draining and checking those drains to make sure you've got rid of all the water. And if the filler cap seals are deteriorating or the seals are starting to perish, that can also help allow water into the tanks as well. So you might want to, before the winter flying season, have a good check of the seals on your fuel tank caps there as well. And if in any doubt as to whether a surface is safe to taxi or operate on, make sure you have a good walk and look around your hangar and the taxiways that you're going to be using on foot as well. You could still get ice even if it's not necessarily visible. A very good friend of mine actually broke his arm pulling his PA28 out of his hangar because he slipped on the ice with the tow bar and his arm hit the propeller. So he'd done all of the right stuff, prepared his aircraft in the hangar, and unfortunately came a cropper actually just trying to pull the aircraft out because of some black ice on the pan that he couldn't see there as well. So that's pre-flight then. The other bit of pre-flight we want to do is some performance planning here as well. These are some charts taken from Skywise. You might see a little addition on the second one. That's because that graphic in Skywise actually has an error in the published one, so we've just corrected it there. The first one is about takeoffs. The second one is about landing here as well. You'll be wanting to use your POH or flight manual techniques appropriate to conditions like soft field. But remember as well that any techniques you use, you should also be following the full detailed configuration and techniques that are in the flight manual, such as the figures that you're getting from your flight manual calculations may include things like running up to full power on the brakes before brake release, which could be a problem on contaminated surfaces or a slippy runway. So do have a think about that as well. And if you look at these factors here, we've given there's some examples there as well about soft ground, dry grass, snow, but you can look and see just how the figures can compound and add up, and they can get to be quite large distances quite quickly. So you really want to take some time and calculate these. Just don't assume that because your aircraft is normally all good to go, actually in the winter conditions, the softer ground, the wet grass or things like that, you may need to take a little bit more care. And another issue, of course, for landing, perhaps just to mention, is the low sun at the end of the day there. And several GA accidents have been caused by poor visibility into sun and that horrible feeling of losing your visual references when landing. If conditions allow, you might want to select a slight tailwind and land with the sun behind you. But again, you need to think about that in your performance calculations there as well. And of course, if you're not night rated or your airfield's not suitable for night flying, you want to leave a suitable margin to ensure you land in daylight. And particularly on those cloudy days like we've had very recently, you'll notice how quickly it gets dark. Of course, it gets dark at the right time, but it just feels very dark. There's no ambient lighting with those real heavy cloud cover days there as well. It feels really quite black and you lose the light very quickly. Let's just move on now and have a quick look at the in-flight situation. So I thought it was amazing. There was 77 of you responded with issues that ICE gave in that earlier section here as well. So most of you picked up on all of these things that we're talking about here, and many more great suggestions came out there as well. The key thing here really is if you're cruising in suspected icing conditions, monitor your airspeed carefully. The loss of speed is the main suggestion that ice is starting to increase the drag and reducing the lift of the wing. And early indications will often be around the edges of windscreens and on things, protrusions like the temperature probe and things like that. Worst icing can often be found in bands of several thousand feet. So you might be able to reduce the severity of your icing by climbing or descending. But if you're worried about performance issues, climbing may put you worse. So don't worry about that as well. But obviously descending is normally the safer option to get into warmer air, but always make sure you're very much aware of terrain and anything of threats on the descent. If you experience severe icing and ice cannot be dispersed from the aircraft, you really have to anticipate control difficulties. And what I would suggest is inform ATC without delay and consider declaring a mayday. It really is that quite serious. Keep the aircraft speed as high as possible, and the stall speed will have increased, but you might not know by how much. The stall warner equally might be frozen and not working. If you can see excessive ice on the wings, there will almost certainly be even more ice on the tail, and this will reduce your elevator authority and make the aircraft heavier in pitch. In extreme encounters, the tail may stall, leading to loss of control. And those of you that are fortunate enough to fly aircraft with autopilot, if the autopilot's engaged, you really want to check that the autopilot's not applying excessive nose-up trim to counter that lift reduction as well. And if you appear to be losing airspeed, you may need to carefully disconnect the autopilot and be ready to deal with an out-of-trim condition. And you may need to descend, as I said, to maintain a safe airspeed. If you've still got significant ice when you're landing, consider adding 20% or more to the approach speed, whatever you need to maintain control. And consider doing a flapless landing as well, since this normally means less elevator authority is needed to maintain that approach attitude and then subsequently round out or flare the aircraft as well. You may want to consider diverting somewhere with a big long runway so that stopping distance isn't an issue as well. And if your windscreen's iced up, make sure you've got demists on, and if possible, open any storm windows or side windows to try and give your visibility there as well. And I was speaking to somebody only today that had a very severe icing encounter actually, and they had to fly a curving approach to land and use visibility out the side because their screen, although it was starting to clear, was still very much obscured. So it can take a long time to disperse if you've really picked up some ice there as well. So finally then, post-flight, what I suggest is clean the aircraft if necessary. If you've encountered mud or slush, when it gets onto the aircraft, it's going to dry or freeze, and it's really, really horrible and difficult to get to remove afterwards as well. And inspect the wheels and brakes to make sure they're free of contamination there as well, because it's just going to give you problems with potentially things freezing on or causing damage for the next pilot or even yourself. And if there's significant water on the wings as well, wiping the worst of it off is helpful as well, because it might just stop it freezing for the next pilot there as well. And carefully make sure you're diligent to install protection things such as control locks and pitot covers to protect those kind of extremities as well. Finally, I'd just like to mention the concept dress to survive. So you really need to ensure you wear suitable clothing for the conditions outside the cockpit as well as being comfortable during the pre-flight checks as well, it's very tempting to kind of, remove all of those layers when you get into the nice warm aircraft cabin. But what you really need to consider is the effect of having to make a forced landing. And particularly in some of the more remote parts of the UK, rescue could be some significant time, and the effects of exposure will set in very quickly if you're not dressed to survive. Remember what we said about the wind chill effect earlier there as well. So I encourage you to dress for outside the aircraft, not necessarily the cockpit environment there as well. Now, under Part 20, under Part NCO, Part 21 aircraft are required to have a fixed emergency locator beacon, or for aircraft with less than 6 passenger seats, you can carry a PLB, as an example shown there as well. Non-Part 21 aircraft are not required to be so equipped, but a PLB and some survival kind of aids are really, I think, worth carrying if you're going to do some winter flying. Things like some good torches, maybe a survival whistle, all these things can be bought very cheaply from either online or camping shops there as well. The example there I've put is a little survival bag. It packs up really small, and basically what happens is a couple of you can sit in and just fit it over you, and it will do wonders to protect you from wind chill and the elements while you wait for rescue, and is quite nice and visible. And that's something you can pick up online. You can get those for about 30 odd quid online, having your flight bag, and it could be a real aid as well. One of my friends hit an unexpected snowstorm, and she totally lost all visual references and ended up forced landing. The aircraft was safe, she was good, but she was ended up being hospitalized because of the effects of hypothermia after a successful precautionary landing, which was very sad. It's fine now, but it's well worth thinking about, just giving yourself that best chance if you have to land out or have a forced landing. Now, what I've talked about is basically all amplified in the excellent CA Safety Sense leaflet on winter flying. It's a new updated one, and I think it's a really good read. And Chloe has put the link in the chat box for that as well. Well worth a read before you go into this winter season. That's it from me. Again, just a few thoughts on things that you might want to think about when applying some of this winter Met stuff. Over to you, Chris.
Lovely, thanks, Matt. Some good advice in there, particularly on the Dress to Survive front. I remember it well. A whole bunch of links going into the chat throughout there, which is brilliant. They will be replicated at the end of this, and we'll send you all these links out in an email afterwards. So don't worry if you haven't managed to click them all and save them as you've gone along. We've had a bunch of questions answered by Joe and Simon as we've gone through as well, but we need some more. You've got us for another 20 odd minutes or so. So if you've got some questions on Met, it doesn't have to be winter Met. We've got the experts on the panel this evening, so feel free to ask away. I've got a couple of questions I'm going to go for now, but while I'm asking these questions, and these particularly taxing questions of our two experts in our pub quiz, please do put some more in the Q&A box. Right then, so question number 1 is from Stephen. He says, please can you ask the team to define the term prevailing visibility, because he finds it confusing. So for one of our forecast team, define the term prevailing visibility, please.
Over to you, Joe.
Thank you very much for that. Okay, so prevailing visibility, it's the greatest visibility value which is reached within half of the horizon circle. So, for example, how best to do it? You might be stood outside having a look at the whole horizon, and you might have 8K in one direction, and then another direction is 12K, and then there's a small section that is say 4K. So actually what you would have, if your 8K and your 12K are the most prevalent, then actually your prevailing viz will be 8K. It's a bit difficult to explain without pictures. As I can recommend, it's not a very exciting document to read. And I can say this with complete honesty because it's my document that I have to update and publish. But if you're ever needing some bedtime reading, I'd suggest having a quick look at CAP 746, which is one of the CAA caps. It's actually to do with METARs and observing. for those ANSPs that provide METARs. But actually, some of the annexes are really kind of quite useful. They provide some kind of practical worked examples of things that you might see. So there's a whole section around prevailing visibility because it is quite complicated, and actually it's best described with a diagram. But I'll see, I can try and dig out those diagrams, Chris, and then perhaps you can send them around afterwards if that's if that's any help. But it might help to explain it more.
Yeah, we'll pop in cap 746, wasn't it? We'll put cap 746 into the chat now for the link, and we'll send that afterwards as well, so everyone can. Well, look at what a great document you're in charge of. In fact, there it is there. Lovely.
You love a good definition, don't we?
Oh, we do.
Oh dear. Right then. Okay, thank you for that. Right, question number 2 is from Dave. This is quite a long one, so here we go. There are a lot of sources of weather information: the Met Office, Aviation and Public, TAFS, METARS, BBC Weather Channel, Windy Weather Radar, YouTube, etc., etc. But does the team have a favourite process when getting their weather, i.e. start with one, check it against another, note additional information from a third element, for example, prior to going flying? So what would be your weather process?
Do you want me to start off with that one?
Go on.
Yeah.
Okay, right. Because I kind of batted the last one over to Joe, didn't I? How do we explain this? Right. So, as forecasters, apps really are a pain. There's no two ways about it, and the reason is that what we can do as pilots is we can look across a myriad of websites to try and find the weather that we want to see. And if you look at enough websites, you are going to see the forecast that you want to see. So we need to be aware of that psychologically as pilots, that there is a human tendency to do that. Now, it's a question that I always get asked at weather school. We do a session actually at weather school on this, and we talk around what apps pilots are using, what data they're looking at when they're using those apps. And what's really interesting is that the majority of the apps, the majority of the websites are using exactly the same data. They'll say there's discrepancies between them, and indeed there are discrepancies between them, but actually those discrepancies usually come about because of update times of the apps. So the conclusion very often of these sessions is that actually what we should be doing as pilots is looking at the official data that's coming out from the Met Office, because it's human forecasters that have looked at that to create things like the TAFs, like Form 215 and like Gamut. And, you know, I'll be the first to put my hand up and say they're not exactly the most user-friendly of documents, but actually the amount of information that they're trying to convey in such a condensed format is really very, very useful. So what I would say is that, and this is the way that I normally play things, and obviously I'm looking at this from a forecasting point of view, from a professional forecaster's point of view, is that if I'm going to go flying, let's say at the weekend on sort of Monday, Tuesday, yeah, you can look at sort of, you can look at apps, you can look at overviews, you can look at the surface charts, you can start to make your own sort of formulate your own idea of what's going to happen. But then once we're getting close to the time that we are going to fly, and let's say we're going to fly today, then it really has to be the TAFs, the Gamut, and the Form 215. If you're going into Europe, use Form 415, because professional forecasters have produced those forecasts. You may not like what you're reading as a pilot that professional forecaster has put, but trust me, they're going to be the best forecasts that you can read. So I know that's a very kind of long-winded answer, and it's not particularly what people want to hear, but interestingly, when we have this discussion at weather school, the conclusion always comes down to use the official forecast that you're seeing, use your own knowledge. That's the best forecasts for flying that you can produce. Sorry about that, I kind of went on there, didn't I? It's a bit of a hobby horse in my mouth.
No, not at all. No, it's
Me
good.
too. Me too.
Good.
What do you think,
No,
Joe?
it's
Would that be your approach to it as well, do you think?
So it would, and I guess this is where like my CAA hat comes in. So the official answer is the Met Office. It is the UK's designated Met provider for regulated aviation information. So that is where you should be going for your information. However, you know, we all know there's loads of apps and there's other sources as well, and they can be really beneficial. I think it's just, if you're going to use those, it's just being able to recognize the limitations. Simon's talked a bit about that in terms of times that the data comes in. Sometimes they don't match up, and those kind of possible risks of using an unregulated site. And I think the other thing that's worth bearing in mind is that if, heaven forbid, there was some kind of incident, the AAIB will always ask you which regulated products you looked at, and we'll be asking questions about the Met Office forecast. And during those investigations, the Met Office will provide the forecasts that were available on the day. So from an official perspective, it's always going to be the Met Office. I think one thing to kind of point out is the aviation briefing portal. The Met Office, it's called Aviation Briefing Service, ABS. That's undergoing a huge revamp at the moment. That's something that the CAA oversees the work of the Met Office, and we have regular meetings with them, and it's one of the aspects that we're overseeing with them at the moment. So there's a huge piece of work going on to update that website. They put out a survey. They had over 2,000 responses. They've spoken individually to people. They've been on visits to airfields, spoken with various different operators. And the idea is to move it off its current platform, put it onto a new platform. And they've really taken sort of on board a lot of things. I've used it myself. Everyone loves Windy. The graphics are great on Windy. So why can't the Met Office get some better graphics? They're going to start with putting the current information that's on that briefing surface portal onto the new one, and then gradually they will add additional information. So there's been a huge number of people who've requested more observation sites, more observational data, or better kind of higher resolution forecasts, more individual site forecasts as well. So a lot of that stuff is all in the pipeline to come. It's an absolutely massive piece of work. There should be a beta version available at the beginning of next year for testing, and the idea is they will run it alongside the current service, and it's very much user-led. So I'd really encourage any of you to get involved. Contact the Met Office. I think the link is still on the Aviation Briefing Service site, but if you need it, I can give you the link. But I definitely get involved, and when the beta version comes out, again, they'll be asking for user feedback to help develop that. That's this is your chance to get involved and make that site much better and much more useful to yourselves. So definitely encourage that.
Oh, good. Didn't know that.
Jump into just two things there. So firstly, on what Joe said, firstly, the CAA pay the Met Office a lot of money to produce aviation forecasts. Okay, so that's why you're getting the quality of the human forecasters producing those forecasts, because they're paid to do that job. That really couldn't happen within the private sector in the same way that it happens with the Met Office. So that's why it's really important that you use the official forecasts. And secondly, Joe mentioned the AIIBs there. I've been involved with investigations where we've needed proof that the pilots accessed official Met data, and it's been very, very difficult to prove. So if you're going flying, what I always say is print out a 215 or save a screenshot, even if it's on your phone, to prove that you got that official Met data. Just to have that proof there, trust me, saves a lot of heartache in the future.
Good to know. Good to know. We've got a slide coming up on the ABS shortly, which we'll come to after the Q&A. But thank you for that. Really good information. I didn't know that it was changing next year, so look forward to that. I use ABS quite a lot. Okay, right. This one's for you, Matt. Let's go slightly left of field here. From Mike, he says, "Do you have any tips on starting a cold, normally aspirated engine?" Come on.
Well, first things first is to follow your flight manual or engine manufacturer procedures. A lot of people try and do things slightly differently to what's actually recommended in the manuals. And if you're using kind of local club checklists as well, it's worth looking to see, are those checklists actually reflecting the practices that are recommended by the engine and airframe manufacturer. The main thing that people struggle to start normally aspirated engines is two things. Either firstly, they overprime, as in they think it's very cold, I'm going to give it 2 or 3 extra primes for good luck. And then you've got an overprimed engine. And that can obviously bring in all of the risks of engine fire on start and things like that as well, which we don't want to start. But the main problem I often observe with students and test candidates is that they have the throttle too widely open on start. If you look at most checklists, say for a PA28, it will say 1/4 of an inch open. That's not 1/4 of the way open, it's 1/4 of an inch, which is actually the throttle only just open from the idle position. And a lot of people try and start the engine with the throttle too wide open. And then, of course, they're cranking, and then it's not starting, so they give it more primes and induce more fuel in and things like that as well. So that's my top tip, is to really look yourself or your students, look at just how much they've got the throttle open. If they're having it too widely open on start, that's when you'll struggle to get the engine started.
Good stuff. Thank you. Right, this one's on fog from Malcolm. Do you have any guidance on predicting the return of fog after it has cleared?
Ooh.
Discuss. Interesting one. I would have thought if it was cleared, it wouldn't come back, but
well, it can come back, Chris. What tends to happen? And again, Joe, jump in here if I'm kind of wrong with this. But what tends to happen is sometimes you can get the return of fog if, let's use the scenario where you're on a winter's morning, you've got fog, and the fog clears, perhaps because the breeze picks up, perhaps because temperatures rise, and that clears the fog. However, and it would only happen at certain times of year, if you then get clear skies because the fog has cleared, temperatures can fall away again and bring you back down to the fog point. So you could get the reformation of fog under those circumstances. Also, what I've seen happen is where you can get radiation fog clear in a morning and almost immediately be replaced by advection fog. So this would be fog coming in because, well, let's say warm air is coming off the sea as a front approaches. So you can switch types of fog from radiation into advection fog potentially as well. But that would be what I would look towards the reformation, would be basically it clears away, skies clear, temperatures fall away, fog reforms once again. I think that would be the most likely scenario. Joe, do you think?
Mm-hmm. I would agree with that, yeah.
The thing, if you're going to do like night flying or early morning flying or anything like that, the thing I keep an absolute hawk eye on is the split between the temperature and the dew point, especially with night flying as well. If you've had if you've got moist air, moist day, and you've got that temperature dropping down towards the dew point or it's hovering around it, that's what you really need to keep an eye on and worry about there as well. I was at Oxford last year, and we had a situation, I think, because there was some kind of built up areas and buildings and that as well, and the temperature was hovering around the dew point. And what was happening was fog was forming in patches around the airfield. So bits of the airfield were starting to build up with fog. Other bits are okay. The grass parking areas were starting to fog, but the runways were okay because it was a bit warmer surface there as well. Really, really strange weather. And, of course, the forecasts can mislead you slightly as well when it is that kind of patchy situation around the airfield there as well.
Yeah. I mean, you can get it just on the knife edge, can't you, Matt? And that kind of shows that probably in that circumstance, a 0.1, 0.2 degrees Celsius difference in temperature was enough to either make fog or no fog. And that's the difficulty that we face as forecasters, really, is that super critical temperature that can sometimes occur. And just picking up on that, Matt, as well, one thing that can happen, and particularly for evening flying, this is something to be aware of, is that if you're flying in clear skies, and let's say you've got variable winds or just almost light winds and the visibility is really good, just be aware that sometimes if you've got a ridge that's causing that situation, but the ridge is moving away, should the winds, let's say we experience it here in the Midlands, where let's say the winds go into the southwest, that can bring in slightly more moist air, which is coming in from sort of the event, it would have been the Atlantic and then through sort of the Bristol Channel, Irish Sea area. That can bring in more moist air, which can be sufficient just to tip us over into fog. Now, I'm not saying that would instantly form, but it is just being aware of those sort of subtle differences that take place, and use the rule of thumb in the UK that things coming in from the southwest, air coming in from the southwest is going to be generally more moist than air coming in from the north, which tends to be drier. And again, it's just these sort of little flags that you can use that tell us the intricacies or increase the risk of the formation of fog.
That's why the apple and fruit growing industry and all those big greenhouses are in the Evesham area for exactly that reason.
Absolutely.
There you go. There's a pub quiz answer for you. Yeah.
Absolutely. And that's why Halfpenny Green's the worst place in the world to put an airfield.
So one thing I'm now discovering is we are forming a pub quiz team. Anyway, right. That's.
Don't ask me any
think
music questions. I'll be useless at that.
we're getting close to time, so I'm going to wrap now, I think, because we don't have time for another question, I'm afraid. But right, let's have a little look at what we've got left. We have some Met Office pilot stuff. Right, so we've mentioned this quite a few times this evening already. This is really important. Joe's mentioned it, and obviously we talked about the fact it's got to get updated next year. Met Office Aviation Briefing Service. So that link will go into the chat box now. Again, it'll get sent out to you afterwards. If you haven't got this or you haven't signed up to it, then please do. It's free to sign up to. Whole bunch of resources on there. Really good stuff in terms of looking at METAR decodes, TAF decodes, 215s, all that good stuff. So I would thoroughly recommend a look through that if you don't have that already. We're going to be sending out a whole bunch of stuff after this as well in terms of the winter flying safety sense leaflets, some clued up stuff as well. So keep an eye out for that in the links post this. I've got 2 more slides. Right, this one, thank you very much for everybody. Thank you very much to the team. We do hope that you've been able to take something away from this evening. There will be a survey that will pop up in your window at the end of this. Please, we would like your feedback, so take the time to fill it in. Our next event is an EFATO workshop. We don't normally advertise these, but I'm going to advertise this one now. It's going to be on the 13th of December, Wednesday the 13th of December, date for your diary, 7:30. The link for the sign-ups again will be emailed to you along with the replay of this workshop and all the other links we mentioned this evening. So EFATO workshop, 13th of December, see you there. One final plug from me is for Simon. I would just like to advertise his weather school. Mentioned it a couple of times this evening already. However, he is super busy. All of his upcoming courses are actually full, but he is going to announce some new ones, aren't you, Simon?
Yeah. We've got new ones coming up soon.
Brilliant. So if you do want to be the first to know about these new dates, then please use the contact form at weatherschool.co.uk, or you can email him directly. And please do feel free to email him at simon@weatherschool.co.uk, either asking about that or any other pub quiz questions you wish. We have, however, run out of time this evening. So all that remains for me to say is a big thank you to Matt, Joe, Simon, and Chloe, working interfactually behind the scenes. And thank you to you all for your participation. Some good stuff in the chat box, some good Q&A. And again, I look forward to seeing you on the 13th at the EFATO workshop. Good evening.
Thanks, everybody.
Thanks all.